Hello judges. Our team has come up with a solution to for overcoming the shortcomings of the modern proximity trackers. Most proximity trackers require users to have a smartphone supporting Bluetooth Low Energy API. For example, Android users must have a version of Android KitKat or greater, and for that tracking to be effective, a large percentage of the population must be using this application. Now that is impossible to achieve in large populations with low income group proportions. To solve that, we have allowed multiple users to register on a single smartphone. The owner of the smartphone can register as a parent user, and the people he lives with can register as user. Now, each user can first register with an Azure Active Directory B2C registration service, and then he can open up his the detail screen of his account and use the features. First of all, he can easily switch on Bluetooth and leave the house to use the general Bluetooth tracking feature. Now, if one of the users leaves with the full smartphone, the others are not part of the tracking technique. So in that case, uh, the other smartphone users and also a special type of account called the desk account. Desk account can take this person attendance using phone numbers. Now this desk account is for places of gatherings like aircraft cabins, classrooms, meeting halls, reception counters, where the person in charge can set up an account and take attendance of the people getting in there through Bluetooth scanning, and also record attendance using the sign in feature I was talking about. The person without the smartphone can give up his phone number or register using for phone email address, and upon after the signing in, the person is not logged in into this phone, but instead uh, this phone number and email address is sent to an Azure function, which then generates a unique code with a timestamp and sends it to a temporary document pertaining to this email address or mobile account. And if the person is not an app user, an account is created for him, which he can later use if he registers himself, and the unique code that is stored there is again sent back to this desk operator, which and is stored in his account, so that the two accounts have an identical code, which if any one of them uploads later, can be tracked for identical copies to check if an infected person was in contact with others. And this, there is obviously a password feature for authentication in email, and an OTP feature for authentication in mobile. After the authentication, the Azure function part happens. And now, if someone is already an app user, they can record attendance using showing their QR or scanning from the other person. This QR also contains the same code generation logic, but this one code does not have a timestamp. So the person scanning it gives it a timestamp pertaining to a 10-minute slot in which it was scanned, and the person generating it also gives it a timestamp and records it in his database. So only if the scanning and generation occurred in the same 10-minute slot, only then the interaction is valid, thus forgery of QR is not possible. And this QR refreshes itself, so if this, even if the screen is kept open at a place, people can come in and scan it, and it will keep refreshing itself every 10 minutes. And the scanning of feature is also present inside the app only. And during all this feature is used due to this Azure function and QR feature, and no the account details of any one user is not revealed to the other, and both desk accounts and individual accounts can use this to record attendance. And after testing positive or being diagnosed with COVID-19, a person needs to be interviewed to check where the places he has been to or the people he has interacted with. But reproducing all the details from memory is not possible. In that case, a writing daily log feature is given, and it is invalid for a desk as it is not a personal account. And the individual accounts can write their daily logs pertaining to a date, and that logs are sent to the Azure Natural Language Understanding Model, LUIS, which understands the intent and whether it is a daily log sent utterance, and extracts the key information like location, places, the people or number of people involved, and sends the response back as a JSON string, which is stored with a timestamp in the local database. And since the entire sentence is not stored, the storage requirements are less. And help box instance also provided here. So for either a normal medical trials or COVID-19 assessment or mental health screening, it understands the intent using the LUIS model, and even if in the daily log a sentiment analysis is activated, and a person is seeing the sentiment is seen to be deteriorating day by day, then he can be prompted to or suggested to talk to the chatbot for help. Now all other details are present in our apps and in our PDF, and also in our detailed video. Thank you.